Hello, welcome to another show of Corvid Coder. We're going to get right along with Nuthatch again. So Nuthatch, well, for more information about this stream, if you go to patreon.com/DannyFritz, you can get all the information. The links are probably the best part of this. So if you want to see all the previous streams, you go to the YouTube. If you want to watch the live ones, you can go to Twitch or YouTube. If you want to see all the code that we're writing on the stream, you go to GitHub Corvid Coder. So Nuthatch is a set of utilities for making a game. And all of the code that is written on here is written on the stream live. So every single time I do one of these streams, at the end of it, I do a commit. So it looks like today we're on day 29, which lines up with the number of commits. So let's get to it. Come up with a command. Okay. So let's go into Nuthatch. Let's open up Atom here. Let's open up a new window. Let's go about Firefox, but then I'm going to change it right back. Okay. Put it into Chrome here. Cool. So let's see what sort of stuff we can work on. Linter, some version releases, some demos, documentation, points, lines, text, audio, vector stuff, matrix projection, matrix state, event bus, collision detection, example runtime. Okay. Let's, I think out of this stuff, I think text is beckoning for me finally. Oops. So let's work on text. So text is probably going to be a multiple stream long one. Text in OpenGL and WebGL is not trivial. So let's see what kind of stuff the web offers for us. Actually, Atom is what I want. So I'm going to create a new demo. I guess it'd be a graphics demo. We'll do test because it's a little bit more involved. I want to copy game and index and paste it into text. Okay, so Nuthatch demo text. Game.js is fine. Inside here, we don't need any of this stuff. I just want graphics. So let's just do a graphics stack clear to start off with. Okay. Let's go check out. Oh, I need to add it to the menu. Okay. Let me check my audio levels. Okay, that's good. Making sure I'm actually speaking. So now I should be able to go to text. Okay. So state manager is not defined. I thought I deleted it. Oh no, I mean it's clearly sitting right here. Okay. Okay, so there we go. We have a full black. So technically I want to do something like, so because text is involved, I already know that we're going to need to create like a text object, and it's going to work like a sprite sheet. So maybe it's probably worth talking about different types of fonts and text. So day 29. So I did bring my tablet, so I could do this. Put it on top of my keyboard. Okay. Looks like it's working. Oh, do I not have an undo? I'm wreaking all sorts of havoc right now. Okay. So we're going to talk about text in, can I scroll? Oh, I can. In, we'll say specifically WebGL. In OpenGL, there's tons of libraries you can just pull in and kind of do it and see and stuff. But in WebGL, there's less options. So we have a lot of choices. We can do bitmap. We can do vector. We can do distance field. I feel like there's a fourth one I'm missing. I'm gonna think about it for 1 second here. I mean, I guess there's probably infinite, but oh, okay, yeah. So we'll leave it at these three. We don't need to complicate it too much more. So bitmap. Render font to a sprite sheet. And print text with a sprite batch. So we already have all the infrastructure in here to do the sprite sheet version. So basically we would have something like an image, and it would be kind of like cordoned off. And you'd have something like A, B, C, D, E, F, G, you know, blah, blah, blah. And anytime you want to use a B, you take this sprite and you stamp it down. So that's kind of how a bitmap will work. And there's a lot of times XML is often used to denote Atlas locations. So an atlas is kind of like a spreadsheet. So it's just kind of like a map where it has all of the individual pieces in it. And oftentimes bitmap fonts will come with an XML file that will specify where all these things live and what the dimensions are. Let's talk about vector now. This is most modern fonts. Oh, another asterisk. Scales poorly. However, cheap to draw. I should specify we're talking about size, not like how many letters and stuff. So vector, most modern fonts are vector. We keep a collection. Oh man, writing is hurting my hand again. I think my desk or my lap more or less is too high up for my hand. We keep a collection of lines and curves to describe a letter. So this might mean like A looks like this. Right? That could be an A. That's a pretty poor A, but that's okay. And then like these would have like little handles on it, specifying the spline. And we would have these for each one of those, and then it would be up to our rasterizer to figure out how to parse or how to render these vectors. So the reason why this is why most modern fonts do is this can be scaled infinitely small, infinitely big, and it won't lose any quality. You can change the widths of your lines and it won't lose quality. You could dash it, you can change the color, you could do gradients. The render is completely up to you, so there are so many possibilities for what you do with it. Also, it's tiny. Like if this was truly an A, this would be 1, 2, 3, 4, 5, 6. 6 times... this would be 36 bytes. This right here. Or on a bitmap, this A is probably closer to like 50 by 50. So 2,500 times 4 bytes. You know, this takes up a lot more room. This takes up like 0 room on your file system. It just takes a lot of computation power to, you know, go from a vector to like a bitmap. Okay, so the last one I had on there was distance field. So distance field was created at Valve, I believe. And more or less it's, I don't know, I'm going to try and draw it. Or I should describe it first. It is a mapping of each pixel's distance to the closest part of the letter. So it's a little obtuse. If I can't draw it, I'll just go and Google it. I need like, the reason why it'd be hard to draw is because I need like a gradient. So let's say A looks like this. So we have a nice big capital A here, right? So I'm drawing this place in straight up black because black means that you are as close as possible to the actual letter. So all of this is very close to the letter, so I'm just filling it completely in. This part in here, let me see, like maybe like fill it in a little bit like that. So all of this stuff, you know, is pretty close to a spot on the A. So you kind of fill it in like that. And then all the other stuff, you know, layers. This is much closer. So you fill it in a little bit darker. It's a gradient around it. It's a distance field. And this would all be colored in like that. And then when you can scale this to any size you want. And then what you do in OpenGL is you say, if the alpha is greater than like a half, let's say, then just fill it in with black. And then what that does is it creates this nice sharp A at any size you want. Let's go see if we can go find like a better description of that than my drawing. Distance field font. So let's see, it was used in Team Fortress 2. Okay. Yeah, okay, so a Valve person came up with it. So this is the distance field over here. So this is what it's going to look like. And this is like the distance field. So the further and further away you get from a point on the letter, it gets dark or brighter and brighter, or less and less alpha. So if it's greater than 0.5, you fill it in, and it gives you these nice, almost vector-looking shapes. I guess it talks about how it works. You can use this program to generate them. There's even some GL code for us to use. Here's if you're doing other methods. So if you're just doing a normal font, you need a nearest neighbor, linear. You tried to hack it yourself by doing, I guess, curves. And then here it is with distance field. It's very nice looking. So that's distance field. Let's make this smaller again. For now, or not for now, what I'm going to try and do for this, I'm just trying to draw on my keyboard. What I'm going to do in this library is I'm going to do a bitmap. So, I don't know, I'll just choose red. We're going with bitmap. But we're going to generate bitmap on the fly. On the fly is probably the wrong wording. At upfront using the platform. So basically we're going to be able to tell Nuthatch, it's like, I want this font at this size with these styles, and I want these glyphs or like letters or Unicodes or whatever. And then it will generate that bitmap and store all of that relevant information inside of like a font object that we'll be creating. And then you can use that to print, hopefully, paragraphs. So let's start. I'm almost positive this will be a multi-stream endeavor. Nothing about this is easy. So let's minimize that. Did I delete all the pages? What did I do? Oh, I'm just searching something weird. Okay. So I'm going to close one note. So let's generate our font. So I'm just going to act as if the implementation already exists, and then we're going to use it, and then we'll write it to make it work. So what's a font that I could use? I'm tempted to try a font that I'm going to... Let's go get a Google font and use one of those to prove that you can use any font you want. I want a trendy one. Or I want a display one. Where's my filter? Google, what have you done? Oh, here we go. So let's go grab a display font. Trending. Yeah, okay, that works. Let's take a Lobster. Ooh, I like that. This is like a classic book cover look. Let's take this one. Abril Fat Face. Oh. I know face is a word for a letter set, but I don't know, fat face. Select this font. Okay. Embed this font. I can have extended. Okay. Just give me this font. So I need to put that into my index.html. Oops. All right. And then I don't need that. I need this later. I'll put this in a comment in the JavaScript for now. Okay. Thank you, Google. Let's open up graphics. And then I'm going to remove this tree. Graphics is a big file. Okay. I don't think I need that. So it's going to be font equals graphics dot new font or create font. It's going to be Abril Fat Face. It's going to be size. Let's take a font object actually. I'm just going to make up what a font object is. I'm a developer. I get to make up stuff. Face. Face? What is a font face? That is like actual different fonts, right? Hey, this is what I wanted. Reuse face. And then we have style. Oh, weight, normal. We go with numbers. 400. Size. Let's do a large one. 48. I mean, this would support ems, pixels, numbers. Let's say you have to do a pixel, or you have to do a size. So let's do 2 ems. It's probably good enough for now. I don't like the formatting, so I'm going to format like a C person. There we go. Which glyphs do I want to support? I think that's going to be an array of letters, as annoying as that is. Let's support space, capital H, E, L, O, W, R, D, exclamation, ooh. Okay. And I'm going to move this too for clarity. So these are the letters I want my font to be able to support. I think that's all I need. Okay. So I'm describing the font, and I'm describing the letters I want. And that'll give me back an object. And it's going to be a magical object, but whatever. So after that, I want to do graphics.text, and that's going to take in a font object and hello, Nuthatch. Oh, and a location. Let's do it at 0, 0 for now. Also, I'm pretty sure I want to do an orthographic, so I do need matrix. Otherwise, the font will be like 1 pixel. It'll be like the corner of the screen. Set transform matrix to matrix.orthographic 300 by 300. Okay, is everything okay? Nope. Oh, because this stuff doesn't exist. Okay, so this is the API I want. I'm not going to support mixing styles or anything like that. That'll be in the future. But for now, this is what will have to work. Okay. So the first one I need is create font. And that's going to take in a font object and a glyphs. I should use its characters objects, which is a string array. And that was it, right? Yes. So let's go describe what a font object looks like, and then we'll go do text. So font looks like this. It has a face, which is a string. It has a size, which is a string. And it has a weight, which is a number. Okay. So that's what fonts are supposed to look like. And then we need a text function. And that takes in a, and this needs to return a font object, I guess. We'll call that font face, then return a font. So I don't know what a font looks like yet. This is going to be a font face. I suppose that's family. So I'll go correct that over here. Family is Avril Fat Face. And then it's going to export a font. I don't know what that looks like yet. Illegal return statement. That is curious. Oh, indeed. Takes in a font face, gives back a font. Okay. Text takes in a font and a text or message and returns nothing. Okay. So I'm going to do some more drawing. I have some ideas where I'm supposed to be going with this. Tab it back in there preemptively. So here's how I want to generate the bitmap. So for each of the letters that I pass in, we're going to have a canvas that is something like this large, and we're going to print it here. The reason why we're printing here, I'll talk about that in a second. So then I need to figure out what the bounding box is. So like this would be the bounding box. And then I need to crop it, which a crop tool looks like this, I believe. To like the very minimum it can be. So it needs to be fairly large like this because we can have other letters. So like in Fiora code, we have ligatures that look like this. Actually, they're connected. And you know that's fairly large. We can also have ones that look like this. Which are fairly tall. I just need to be able to handle those sorts of cases. Why here? Why not here? So J's tend to look like this. So if this is where we're drawing our letters, J's go like that. They go under the letter before them. So I need to put it out to the right a little bit. It might be worth talking about some font metrics. So you have a baseline. So I'm not a font person, so I don't know everything. I don't know most things. What is this called? It's like sub. And this is like Ascent. Yeah, I'm like really not a font person. I know this one. So this is a sans serif. That's a serif. It's caps on the end. So if I wanted to make this a little bit more clear, I'm not making this more clear. So these are serifs. It's these caps on the end of your letters. This would be boldness. I can't draw it any thinner. So like this could be like a 100, this could be like a 400, and this could be like a 700 in weight. I suppose all of this doesn't really matter for what we're doing right now. Oh, a big reason for why J goes to the left of where it was drawn, so like if this is 0, 0, and it goes to the left of that, is if I had a word like fjord, if I wrote it out like this, where everything had separation, it would look kind of strange here, right? It looks almost like fjord, like F-jord. So what they generally do is they kern them. They kind of blend where they go together. So there aren't like separating lines you can do here. So this is kerning. Okay. So what I'm going to do is I'm going to put up a canvas. I'm going to draw my letter. I'm going to find the bounding box. Then I'm going to crop to that bounding box. And I'm going to put that in an atlas. So that will go into something like this. And then this will get cropped to something like this. And now I'll also go into my atlas. And eventually I'll have an atlas with, you know, XY coordinates. So like this is green. I know A is there. I know that is there. But it's going to be a little bit more than that. So like when the J comes in, well, we'll draw the green. It's like this is 0, 0, this is 0, 0, and then J comes in. And 0, 0 is actually going to be somewhere like, oh, I didn't want to capitalize J. Zero, 0 here is actually somewhere like here. But then my bounding box, upper left, is here. So I am going to have to keep track of some metrics inside of my atlas. So it needs to know where the bounding box is. It needs to know where the origin is, because there's different spots for each one. And then I also need to know the width. And that'll actually be included in the bounding box. I think I just need to know the origin and width. Okay, so all of that will need to be maintained in the conversion from this over to here. I need to keep track of a lot of the metadata. So let's start. So basically we're going to need a canvas. So const canvas equals document.create element canvas. We need to set the width and size of it. So that would be canvas const width equals font.size. Oh, it needs to be a number. unless calculate CSS size. In JavaScript. Oh no. How do I calculate if I have EMs? Get EM in pixels JavaScript. Okay, so there is something to do it. To get the rendered font size of an element without affecting the DOM, do that. So I'm going to put that in there, comment it out for now, or uncommented. I need to look at it. So I'm not ready to compute the width yet. I need to do this. So const element equals document dot create element. It's going to be a div l.style.width equals font.size. And then we're going to parse float that, and that's going to be width. So let's just console log width for now. Let's see what we got. Nan. What is get computed style? Oh, that's a thing. Okay. It gives me back blank. Oh, because I set the width. Width. Blank. Size. Oh, this is not a string. Whew. Oh, is this supposed to be font size too? Oh yeah, it is. Let me console log font size while I'm at it. 2EM, so that looks valid. I think I need to force the force compute of layout JavaScript. So I need to force a layout on this. So I can just call an offset left and it'll compute the layout. Okay. So I'm going to put a debugger there and I'm just going to look at it. So we have L, which is this. And we have get computed style of L. Holy crap. Like literally everything is blank. I wonder if I need to put a letter in it. L.inner text equals hello. Okay, let's also add it to the document. So document.body.append child L. And let's do that after we do these things. Oh, there we go. Okay. So we have what we, oh boy. Okay, so we have all that stuff we wanted now. Let's delete that and go. And at the end, we just want to is there a remove child? Do I still need that? No. Do I need that? No. So we create a we create an element, we set the font size of it, and then we get the width, and then we remove it. Size in pixels. Okay. So now I want to turn that into a number. Parse float. $32. Okay. So now we have the size in pixels, it's 32. So that means the width is going to be size in pixels times 2, let's say. I don't need to do this canvas yet until down here. Canvas.width equals width. Canvas.height equals width. Okay. So now we want to do we need to get a context 2D canvas out of here. So canvas.getContext. And the reason why we're doing this is because in the rendering 2D context of our canvases is they can print like any font I want. OTFs, TTFs, WAFs, ETFs, SVGs, pretty much anything. So we're just going to utilize that to create our bitmap font. And then we're going to use the bitmap font over in WebGL. So we're going to get a 2D one. Then we're going to say context dot, what is it? Fill text. Let's just fill it with A for now at 0, 0. Oh, and we also need to document.body. Just so we can see it, not for actual use. Document.body.append child. I want to see the canvas. Not impressed. Oh, here it is. Okay. So it's there, I just don't see the A. Oh, it's not going to be null. I wonder why I don't see it. Maybe I don't want 0, 0. Maybe I want like size and px size. I want it in the center. Oh, there it is. Okay, so now let's set up the font. So that'd be context.font, I think. And it's just going to be font.size, font.family. What else did I put inside font? Weight. Weight, how do I do weights? I think here. Font.weight. What kind of weak ass font is that? That is a... Let's get rid of this. Hey, okay. Hey, okay. So I didn't get the weight right. So let's go look at that. So context rendering 2D dot font. Fill text. Actually, font. Oh, there, CSS font. That's what I'm looking for. So, how do I specify a weight? Oh, it goes before the size. So I can put it out here. Oops. Let's see if that doesn't break it. I mean, it just completely ignores it. This is literally the only mention of it. Do I need to specify all of this to specify bold? It does take numbers, right? Yeah, 100 through 900. Interesting. Oh, there's all this down here. So syntax. That is not the syntax I would expect. Oh, here we go. Formal style, or formal syntax. So, so you do need to include all of this. Okay. So font style, just hard code that. I think normal, yeah, normal. Or actually, I can add that to the interface. And I bet in TypeScript somewhere there is, maybe not. I bet there's a num for it though somewhere. So we need style, and then we need variant, and then weight, and then stretch. I guess I can just write inherit. Like none of this I actually want to do. Style is fine. We'll keep style. Oh boy, I need to start using bookmarks. Let's create a mark here. And then let's create a mark here. Okay, so I can go between them now. And let's also create one more mark down here. Oops. So now I can switch between them. Okay, cool. So I'll put style in there, but what does it render out to? I mean, it doesn't. I wonder if I specified something that wasn't 400, if it would actually render out to something else. No. How do I tell this that I don't care? Okay. So we'll leave these off for now. We'll put a to-do. Font style, font variant, font weight. Okay. So we're going to forget about them for now. Let's get our atlas going. Let's create a character bitmap. And that's where all of this is actually going to happen. Oh, I should be able to... We'll do it this way first, and then we'll optimize it once it's super slow. So this would be... I guess I want it here too, kind of, just for testing. We're going to say const letter equals this dot character bitmap. We're going to ask for a, and we're going to ask for it with this font. Oh boy. Well, I guess I can just pass in the font. And then we're going to set that to letter.width, letter.height. Then we're going to say canvas dot, or that's fine. It's going to be context.put image data, and we're just going to put in letter, and we're going to put it at 0, 0. Okay, so now let's make letter actually something we want here. So this is going to take in a letter, or character, which is a string, and a font, which is a font face. I'm going to rename this to sprite. Character sprite. Or just character. Okay. And it returns an image data. Okay, so all this is good to go. I just need to fix it down here. So we're going to pass the number along so I don't have to keep calculating it. That's a pretty expensive move to force a layout. So let's just do it once. What's it complaining about? No, wrong word. Okay. So down here, I need to this is going to move down here. So this is not an expensive operation. Oh, okay, so I guess I'm ready to go. So we are successfully taking this, creating an image out of it, and copying it over to another canvas, which will eventually be our atlas. So I'll make sure that this is clear. This needs to be an atlas. So image data isn't enough either. Export a glyph. Let's call it a glyph. That's going to be an interface. Oops. Actually, I can't see my time. There we go. I don't know why my timer got so large. So I'm going to undo that split just because I never did the split. So we're almost at an hour. I'd like to get the cropping down though before I commit. So not a glyphy, but a glyph. And that's going to contain a Does TypeScript support tuples? I suppose it wouldn't, because that really wouldn't make sense in JavaScript. How does that work? Oh. I'm gonna utilize that. So origin we need to know, which is gonna be a vector 2. Width we're gonna need to know, or size, vector 2. And then we also need a position. It's a little bit unclear what those mean. That's okay. I have to figure this out. So we're not going to return a glyph or an image data. We're going to return a glyph and an image data. So that means this needs to change. It's not going to be character. It's going to be glyph, and image data. We're going to use glyph.size.x. Wow, I cannot spell glyph. Glyph.size.y. And then image data. Let's see where we're at. Okay. Character bitmap is not a function, or its return value is not iterable. Oh, right. I need to return a glyph, which is what I'm creating right now. Do you not like this? Oh, it's not a glyph type. So it's going to be, I'm forgetting like the most important thing. The character it represents. A character, origin, position, and size. Or just say these for now to get going. Oh boy. Let's format this like a C person. Okay. Image data is not defined. Yeah, it probably shouldn't be lowercase. Okay, we got our copy back. Frank's a little bit surprised about that because width and height are 0, I thought. Right? Oh no, I set them to width. Okay, so right now there's no cropping being done. The width is the size of the canvas. Oh man, this sun. Create Glyph is really what this should be called. Oh wow. I just keep putting the Y at the end. Okay. Okay. So I think I want to do some testing stuff. So I want to draw lines at where the origin is in this thing. So we're going to do context.begin path, context.move to, size in px 0, context.line to, context.stroke path. This is just stroke. Oh, it is a stroke. Okay. Oh, also, I want to pull this image data before I do any of this. And then I'm going to return the image data. Okay. So now I need one for the baseline. And that's going to go from 0 size in px to width size in px. Okay. Now I'm going to show you what the J looks like in okay, so see how the J goes to the left of the origin here? Okay, so I actually want to move the origin over a little bit. I think 0, 0 is not the right spot. This is all wasted space here. And we need to be able to support like really long characters like that. So we'll stick with J, because that's the one that goes to the left in English. First of all, I want these to be like light red. Stroke style, I guess. I wonder what's supposed to go here. Red. Okay. HSLA, 0, 100%, 50%, 0.5, 0.25. All right. Make it a little bit more than that, I guess. And can I like dotted, dash, dashed? Okay. Context rendering 2D dashed stroke. Stroke dash array. Set line dash. Yeah, it looks good. I want to reverse it a little bit though. I want it to be 15 long and then a 5 break. Well, let's just 5 and 5. Is it like a stroke width? Context rendering 2D stroke width. That is SVG. Okay, just gonna ignore it. So I want to move this origin to the left. So const origin equals x, y. All right. This is going to be size in px divided by 2, let's say, and then y will be size in px times 2 divided by 3. And then I'll have to do origin.x, origin.y, and we now have our origin, so oh, it's not that simple. Oops. Oh, this stuff changed. Okay. So this origin is not what I wanted. Maybe I do want to just divide by 3. Oh, no. Why is... Oh, that's right. I want to do 5/3. Okay, that's a little bit ridiculous. How about 4/3? Okay, that looks reasonable. So if I change the size that I'm trying to draw, does it dynamically change the size of the canvas? Why, yes it does. Okay, so this is looking pretty good. So now I need to do the bounding box. So I need to go over image data and find each edge. So I'll draw this out. To get the bounding box of, say, something like A, what we're going to do is we're going to scan this column and see if there's any A in it. Scan this column. Keep going until we have a hit. And then we're going to take that X value, and that's our bounding box. Then we're going to do the same for every other case. So we're going to go down each row until we have a hit. And then we're going to go to the left each column until we have a hit. And then we're going to go up each column until we have a hit. And that will give us our bounding box. we'll have this box left over here. So it's an expensive operation, especially to do per letter, but it only has to be done once up front. So we need 4 double for loops. I'm going to want to do this in helpers because otherwise I'm going to need for loop labels, which I don't like. I don't like for loop labels. I'll write it once with a for loop label, just so you can see. So let's do let's go from left to right first. So var x equals 0, x is less than or equal to width x plus plus. For var y equals 0, y is less than or equal to width, because these are square, y plus plus. I should probably make it so, yeah. I'm going to say height equals to width up here, and then we use height in the rest of it. These should really be proportional to width and height. So width divided by 3, height should be times 2 divided by 3. No, say exactly what, okay. Oh yeah, because width and height are the same. Height height. Okay, so if I ever do want to change, I don't want it to be square anymore, which I probably won't because it looks like there's a lot of headroom. I'll be able to do that. Unused label. I'm surprised TypeScript even keeps track of that. So let's get a alpha out of there. So that would be image data of x plus y times width so that'd be my R. Okay, so let's talk about what image data is. So image data looks like this. Oops. It's an object with a width, which is a number, a height, which is a number, and a data, which is a u int 8 clamped array, I believe. I'm just going to write array because I'm not sure. I think it's clamped. And the one thing to know about this data would look like something like this. Or let's draw an image first. So let's just have a 4-pixel image here. So these are our 4 pixels. We're going to have a red one. We're going to have a green one. We have a green one, and then we have a transparent one. So what this would equal in image data is width 2, height 2, data, and just believe me that it's a uint 8 array. I'm going to write it out, just a normal array though. So 255, that's a full red, comma, 0 green, 0 blue, 255 full alpha, comma, 0 red. So the first pixel is all 4 of these values. The second pixel is going to be the next 4 values. So 0, 255 on the green, 0 on the blue, and 255 on the alpha. And I'm going to wrap around. The next one is 0 on the red, 255 on the green, 0 on the blue, and 255 on the alpha. And then I said transparent, so it's going to be 0, 0, 0, 0. So there is our image data for this image. So every 4 elements in the array is a single pixel. So this is the same as this. This is the same as this. Yeah, okay, that's good enough. So knowing that, I am only curious about the alpha. So I'm going to add 3 to this. And then I need to go every 4. So multiply by 4. So this should be every alpha left, or top to bottom, left to right. If a is greater than 0, break outer. And I guess we need a variable here. So let temp equals, just let temp. T equals x. Then after the outer loop, we're going to console.log t. Let's see what we got. Image data is not defined. It's supposed to be image data anyways. Undefined. So let's console.log some of these. There should be a lot of them. There shouldn't just be some. Oh, wow. We're getting a lot of undefines, which is interesting. Oh, wow. Undefined. So when I get down to the bottom row, I'm not doing something correctly. So x should be an offset from the left. Then y should be an offset from the top. Plus 3. Should I move it out there? Okay, that looks better. However, we're getting all zeros. Oh, it really needs to be in there. Let's get rid of that. Let's just see if we can get all the r's. Is width correct? Y times width. I mean, that looks correct. Every row will be width long. So the next one I need to skip the top. Yeah, these undefines are interesting. So we do x comma y comma a then. So undefines are definitely always at the bottom. For some reason when we get to the should not be less than or equal to, just less than. Okay. This still doesn't explain the massive amounts of zeros. So that's R. Here's G. Here's B. And here's A. Oh, interesting. I think I might want to just have a look at image data. So here's image data for me to look at. There's a height, a width, and there's a data. So let's look at the first 1,000. Oh, well, let's look through these. Okay, let's look through these. That is an awful lot of zeros. This is a a tiring manual process right now. Or tedious, I should say. Is my J invisible? Let's go to a smaller letter. Let's make it 0.5 EM, or 0.4, sure. So there's a teeny, teeny, teeny little one down there. But it should be a lot more manageable in terms of data. Yeah. All zeros. All zeros. Oh. Okay. Okay. And did it... Huh, but this printed all zeros. So let's make it a little bit larger again. Let's make it just one standard size. So I get rid of the equal thens. All right, let's just explode this out. I expect this to go very, very, very slow. So let's just print out RGBA. What are these undefineds? So let's see. So weird. I feel like there's a really obvious typo in here that I'm just not seeing. X plus y times width. Oh. I have these backwards. Kind of. This seems to be the very last thing I do is these offsets, not the first thing. Otherwise, this becomes 4, 8, and 12. Ah. There we go. Okay, so I don't care about these. I only care about that. There we go. So this is what you would do to calculate the left bound of it. However, this is ugly, right? I'm breaking out of a specific loop. So if I just did break, it would only break out of the inner loop. So you can put a label on your for loop, and that can break out of that. However, it's still really ugly. So I think we need 4 helpers, 4 helper functions here. Get left bound. And it takes in image data. That should be enough. And it returns a number. And then we're pretty much going to do this inside of there, but instead of an outer loop with a break, we're just going to return our answer. So we no longer need this. And we don't need a variable anymore. We're just going to say return x. So we need 4 of these, 1 for each direction we're going. It doesn't like about this. Oh, it doesn't know what width is. I think I can do this. I think the compiler can help me with that because they're read-only. You can't write to them, so it should be able to optimize that. So now, instead of this, we're going to call... Oh, no, I need all that. I already deleted it. It's const, or yeah, until we get a better handle on it, we're going to say get left bound image data, or this dot, thank you TypeScript, and let's console.log L. See if we still get 9. Nope. Okay. Let's just do the optimization for the compiler. Because I am not so sure that the compiler will be as good at optimizing this one. So let's just go ahead and delete that and that. 9, cool. So let's do a get right bound. And this will be the same, except for x will start at width -1. Yep. It will be greater than 0 or equal to, and it will x minus minus. And then we're going to return x plus 1. I believe. And this will probably be x minus 1 actually. Let's just see what our bounding boxes look like. No. Really bad at capitalizing the D apparently. Can I say yes, we do return something? I guess I'll just assert false. Didn't find bound. I don't have assert in here? Well, I better get assert. Let's see, let's go to our markers. Can I say or never? It technically should be a never, but I'm fine with void for now. Actually, these are bad asserts. Actually, I don't know what the character is. You know what? We return -1. Because if we do the throw one layer above, we can actually include the character in the error. Let's see what our right bound is now. $15. Now let's do 2 more. Let's do bottom and top. Top, bottom. Get top bound, bottom bound. So those don't exist yet. So to do the top, we're going to go by y first, and then do x. And we're going to go, so this is going to be get bottom bound. And then let's do the top. We're going to go from x equals 0 to y is greater than height. Oh, sorry. X is greater than width. I don't know why I decided to do that. All right. And these should also return y's. What? Should be y minus 1, and that should be y plus 1. All right, so let's console log t and b. Oh, -1. Let's go look at our get top bound then. Something's wrong. Y from 0 to height. X from 0. I need to flip this. There we go. Okay, so now let's draw the bound in here. Let's make the letter bigger so we can see it. So now let's draw the bound in here. So I want to see a blue box around here. Where's my debug stuff? Here. I want a different color. I want it to be blue. I don't know. What is blue? Like 240 maybe. I'm going to say context.begin path. Context.move to. We're going to move to RT. That is the, or LT. That is the left top. Wait, what? Oh. Needs to be done before this. Okay, I can get rid of the voids now. So everywhere we find that, just go ahead and delete it. Okay. Okay. Line 2. Let's go to the right top. Line 2, the right bottom. Line 2, the left bottom. Line 2, the left top, and then stroke it. Well, that's a tiny little box. I guess from 27 to 29 and 31 to 42, we'd expect a tiny little box. So let's fix that. These bounding boxes are clearly wrong. Okay. So left bounding box goes from left to right, top to bottom. I suppose this one doesn't actually matter. And right bounding box goes from right to left, top to bottom. Oh, X. And the top is going to be, that might have been it. Oh, okay. I mean, that looks better. That is bad though. Okay. So now top to bottom, it goes from top or bottom or top to bottom, and then it does the same thing again. Okay, so let's reverse this one. Starts at height minus 1, goes until height is greater than or equal to 0, and then y minus minus. There we go. There's a bounding box. let's get rid of that stipple. Do I just like set it to false or something? True. What does this function take? Tell me. 5, 0. Okay. Let's make it even bigger. Okay, so now we can get a really good look at it. So, okay. So the top looks like it went into it a little bit. So I have a feeling that these pluses and minuses are backwards. Ah, yeah, they are. Oh, wait. I keep throwing this a plus. Okay, and then the left and right. On the right side, I want to +1. There we go. There's a bounding box. Here's an origin. Here's a bounding box. Whew. Let's try another letter. So that was J. Can we do... Oh, I'm like completely lost. So I know it's in create glyph that I want. Create a marker here real quick. Actually, I want even another one here. So create glyph. Somewhere in here I wrote the letter J. Oh, it's right here, character. So it's actually not here, it's up here. Okay, there it is. Let's do the letter capital Q. Oh, cool. So Q goes underneath the baseline. I feel like I want 1 pixel around them, like padding. Okay. Let's do F. There's one more metric I want in my glyph. So in a glyph I have an origin, a position, and a size. Or bound. Size is good, so width and height plus position, and origin is this right here. I want a spacing. I want like a width, that's just a number. And this is the one that the browser is going to tell me where the next letter should go. So in order to calculate that, oh gosh, what? Oh yeah. So I just added in a width. Please let me see. So the width is going to be something like, no, spacing, we'll call it. So that means I need to calculate spacing. Well, that's done at this level, which is interesting. Or no, it's not. It's done at this level. Where do I do a fill text? Right here. So I also want to do a, oops, const spacing equals context.measureText. So I love this. There's this measure text thing in here, but check out all the information it gives you. It gives you just the width, which isn't even correct. So dot width, and let's put that on here too. Let's put that as a red line. All right, we can change the color. Let's make it green. RGB. Guessing that's green. So it's actually going to be spacing 0, height, and spacing. Origin.x plus that. So it says this is where the end of the f should be, which is correct. A bit more. So I can even draw a double letter here to show it. So if we do like an FJ, the J should start right here, right? And that is where it starts. You know, it's kind of like underneath the F. So I need to keep track of this metric, this little line here. So let's look at J. It says the next one should be right here. Let's check that out. Oh, J is probably a bad one to use there. Oh my gosh. Yeah, so there's a little bit of space after the J for the next letter. And that is, you know, calculated out here. So I want to calculate this from the origin. That'd be the spacing. So I just do minus 0, kind of. So I think that's all of the metrics I want in my glyphs. Change this over to false. Although it is quite pretty. So spacing, I can just leave it as is. Position, I think that's in the atlas. So I just need to leave it as 0, 0 for now. Origin, that is going to be what's that going to be? Size is R minus L and T minus B. Origin needs to be this right here. So if I'm going to move this part to this part, I need to subtract out, oh gosh. If this is 10 and this is 9, I want it to be 1. So this minus that, okay. Origin minus left, okay. And then y will be origin.y minus t. Position, we leave it 0, 0. That's the atlas's job. And then spacing. I think this is enough for me to go off of. So spacing needs to be calculated from the origin. This is not the right place for it. This is the right place for it. I like spacing. Let's just write it all in one. I'm going to do this. Oops. Origin, the meaning of the letters, baseline, position, location of sprite in sprite sheet, size, bounding box of the glyph, or of the letter, of the sprite. Okay, so let's go down, fix some of these errors. Okay. Let's do the whole alphabet, and let's do it slowly so we can look at them. Or let's just do the ones we're requesting actually. So characters dot for each. Oh, I guess I want all this so I can look at them. And then I want a set. Oh, there's such a thing as asleep, is there? Let's just see what it does. Oh. Hardcoded J. Let's see. Oh. The space didn't go over very well. Is it just the H that didn't go over very well? Is this the space? What letters am I asking for? Hello, Nuthatch. What is this? What's with all these tiny... Oh, these are the where they came from. Right. Oh no, these are these are when they went to, and they're just kind of obliterated. Did none of them work? Look at, let's add a J in there. I swear J was just working. This have to be the first one. Interesting. So there's nothing to do with the J. We'll leave it there anyways. Oh, it's because I'm calculating these now. So I need to grab the image data differently when I return it. So the image data isn't the thing that I've been iterating over. It's going to be left top R minus L T minus B. Nope. Oh wait. Looks like I grabbed this. Left top, width, height. B minus D. There we go. However, the letters are being tainted. Glyph image data. There we go. Did it error? Okay, so it's erroring on the space. So I think we need to have a special case for when it's a space. Also, we probably don't need to append these to the body anymore. Where am I even doing that? Doing that right here. And if I put false on this now, okay. So let's work on space. That's a special one. If character is equal to a space, character equals an M. And then we do something special here. Just get a straight up return something. Wait. Now we can return something. So it's basically going to be one tall. It's going to be the width of an M. The origin is going to be this unchanged. And the spacing is going to be, okay. So the image data now is not going to be that. It's going to be context.create image data. I guess I can't capitalize a D. I don't understand what it's saying. So mdn.o/create image data. Pretty much we just want something blank. We don't want any alpha, width, and height. So the width is r minus L, and the height is 1. Let's see if we can get past the space now. The source width is 0. Graphics line 93. Okay, so it's not actually line 93. It's not actually line 93. What line is it then? Be nice to get the TypeScript. Failed to execute create image data. Source width is 0. Let's see. So that's happening from this. R minus L. Oh, because I never actually said put the M in there. There we go, okay. Oh wow, that's big. What? Oh, it's just, okay. Is that really the width of an M? I guess I can find out. Maybe an N would be more apt. Common width of a space. Let's just see what the internet says. Character. White space. I feel like it was going to be the width of an M, but that didn't seem right. That seemed really wide. Okay, this isn't that useful. I just want to know in general, how wide are they? One-fifth M to 1/3 M. Oh wow, okay. So I can calculate that out. I don't need any of that. Just get return. So the way I did that before was with this jazz. So it says 1/5 M to 1/3 M. Let's stick with 1/4. Just do the in between. So I guess that would look like this. This really should be %. Okay, so rename this to spacing because I can. Origin is 0, 0. size is spacing hiccup 1, and the position is 0, 0. I don't know what he's doing. Cat, you're 40 minutes early if you're just looking for food. Okay. So that should be a space. Or a crash. Or wait. All right. Oh gosh, I see. I got these backwards. Actually, I don't even need this. Because I do a return, I can just exit early and then continue. Okay. How big is it ending up being? Something's weird. Oh, it's appending the... Don't do that. Do I have to do that? There we go. Okay, let's go for a 1/4. Let's go for a 1/3. You know, I'm not seeing any difference. Let's just go for a 3M. Okay, I guess it is making a small difference. What about 30M? Okay. Okay, so that kind of proves it is. Let's stick with the 1/3. So, I think that was pretty good progress. I'm going to go ahead and call the stream here, though. We have our glyphs and we have our metrics. We just have to put it into a sprite sheet now. And then after we put it into a sprite sheet, we need to create a method that automatically draws to the screen the things we ask it to. I want to do some timing on this too real quick. I suspect it's pretty slow, but let's see. Generate. Just great font. So to calculate those took 58 milliseconds. Not horrible. Let me try this real quick. So what if I just try to calculate it out, you know, like 4 times as much? 88 milliseconds. Okay. Let's calculate out the whole alphabet, actually. Let's just do it all. Hey. Okay, let's store a global or a thing in here we can grab. Export const English. I'm not so sure. So A, B, and then let's pull in English. And then instead of saying we want that, we want English. Yeah. So, okay. So there's the beginning of it. C, D, E, F, G, H, I, A, B, C, E, F, G, H, I, J, K, L, M, N, O, P, Q, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. So let's pull M up to the line above and put N down a line. Okay. Let's copy these and then uppercase them all. Okay. And let's do 1 or 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and then let's do exclamation point at pound dollar. I should probably be creating a macro at this point. I'm almost done, so it's not that big of a deal. Somewhere I got off. Maybe not. Oh, I see. Let's move these. Oh wait. Let's get 0 in here. And let's get 1 back in there. There we go. Okay, it's lined up. So then we have some symbols. Let's stick to how I was doing it before. Why are you creating all these? Okay. Okay, so that appears to be all of the characters. Oh. That appears to be all of the characters on my keyboard. Yes, cat, I will bring you food, don't you worry. So let's get all the shifts out of those. Oh, that was a shift. Okay, let's see how long that takes. So there's the whole alphabet. 208 milliseconds. Took a fifth of a second. Look at that queue. I hope the baseline is down there. Let me bring that debug back out, just so we can inspect them. What? Oh. That's kind of the point. So that capital Q especially... Okay, the Q looks great. So the origin is right through there. How do I disable this? I know there's a way to do it. Enter, please. Enter, please. Okay. So it says unreachable code. TypeScript, ignore unreachable code. There should be a way to do it with comments. TypeScript 2.6. Oh, look at that. That's even the example they gave. Okay. Let me go through some of these other ones. Assert is declared but never used. That's true. Font is declared. It's never read. Yes, because I'm not ready for that. Message, okay. A function who's declared. Yes, because I'm not ready for that. So those are good errors to have for when I come back. This needs to be an atlas. Okay, that's true. So we're actually going to say const glyphs equals that. And we're not going to do these. All of this is not ready. Reason being is I need the width of the canvas before I can create the sprite sheet. And then turn it into a texture. Whew. Okay. Well, cool. That was a very long stream. We still need more time for font, but I feel like we got most of the hard work done. We're ready to start creating our generative bitmaps on the fly. And one of the nice things is if people want to do all capitals, then they can, their bitmap they'll generate will be half as big. If they want to do ligatures, this will also support that. Well, I should probably hold my tongue on that a little bit because I don't think my first implementation will support ligatures, but I do plan on offering a way to do that because I do think ligatures are important. I think my cat bit my power cord. Okay, so with that, thank you for watching. You just watched an episode of Corvid Coder where we worked on Nuthatch. It's the game engine tools. It's less than an engine, but it's more like a library, I guess, game library. I don't really hear that much though. So if you liked what you saw, go ahead and click like or subscribe on YouTube or follow on Twitch if you want to be notified when I'm live. If you're curious, go ahead and write in the comments about anything, or if you just want to say something nice or mean, I suppose. I will go ahead and stage this and get this ready for committing, and then I'll end the stream. I'm not going to look at them. Commit message, day 29. Commit. Push. All right. Thanks, everyone. Had fun. It's always so much fun.